Hello, today we will be doing this assignment here for March 4th, okay? So open that link up. Okay, the first thing is you've already clicked on this, so that means that you're on the link. The next thing is here's the assignment, and the next thing is document for translations is good. So go ahead and download that one so that you have that. And here's the question stems. Okay, so that's going to be this one right here, okay? And that way you can do a translation on them if you need to, okay? Okay, the next thing is here is the assignment right here. So when you open that up, you're going to see this assignment um, right here. You'll see assignment for lesson March. So this is, oops, Control Z. You'll see this assignment right here, okay? March 4th, exponential function. Today we're going to do something called decay. So make sure you go back and to read the notes, the translations, because this is the very important right here. This decay means it's exponential, but it's getting smaller. Growth is getting bigger, but decay is getting smaller, okay? So make sure you read this for the first two questions, all this right here, and translate it if you need to. Okay. So the first question we get is this one right here. We've seen this before. This table says the number of periods of time right here, how much time, and how many visitors at a park right here, okay? So question number one, does table A, this one, show growth or decay? A decay factor. Well, what you have to do is you have to find out what is happening to VT, or the visitors. This is the visitors when time gets bigger. So when time goes to 0, we start at 100. After another period, now it's 104, so it's getting bigger. After time 2, it's now 196. So now this is getting bigger. So as as this gets bigger, the time gets bigger. It's going up, right? What's happening to this? It's also getting bigger, right? So 100 goes to 140, 140 goes to 190. So as time gets bigger, VT gets bigger also, okay? So that's the important thing to understand about that. So that would be growth. So table A is going to be growth, okay? Now what's happening here is time gets bigger, goes from 0 to 1. Then what happens to VT? Well, it goes from 100 to 60, so it goes down, right? So it gets smaller, and then it goes to 36, smaller, smaller. So it gets smaller, right? As T gets bigger, then VT gets smaller. So that's decay. So the word decay means getting smaller. Gets smaller, okay? Okay, so that's very important. So that's the first two answers for questions number 1 and 2. So I will let you do this one right here on your own, okay? Oh, wait, no, I take that back. Okay, that's the first question type, okay? Now, what I'll let you do for the assignment is now you can practice and practice questions 3 and 4. Use these two tables here and go ahead and get those, okay? So the next thing we're going to do is we're going to look at questions 5 through 10. So make sure you go to the translation and look at, first of all, I want you to read the steps in solving for 5 through, and then also read that. And these are the question stems, okay? Okay, so now that we're here, so questions 5 through 10, same thing. This is the money. MT is the money. After T periods of time, T periods, this is your money. Is it linear or exponential? Well, here, there's two things we do. So if we look at, so we start with the second one, right? Oops. So let me go back to this one over here. Okay, so what I'm going to do is I'm going to look at, so I look at this one right here. So I look at, we have 1600, so I go 1600, the second one. minus the first one, 2,000, is minus 400, okay? So that can still be linear if it continues, the pattern continues. But then we're going to take, so we go 2,000 minus 400 equals 1,600, correct? That's what this is right here. So that's okay. Then we're going to, does the pattern continue? Minus 400, that's equal to 1,200, right? But this is 1280, so that doesn't, the pattern does not continue. So that means it's not minus 400. Now we're going to try something else. Now we're going to try division to see if it's exponential. So it's not linear. I mean, it has to be exponential, but let me show you how. So I go 1,600. Remember, to try exponential, we go divided by 2,000. And that is equal to, if you do your calculator, so you go 1,600 divided by 2,000. Enter, and that is 0.8. So that is 0.8. Well, let's see if it continues. That means if we go 2,000 times 0.8, we get 1,600. Okay, we'll try it on the calculator, right? So we go 2,000 times 0.8, enter, 1,600, okay? But now we want to see what the next one should be. The next one should be 1,280, is it? Here we go, 1,600 times 0.8. What is it equal to? Let's see. So we go, so I already have 16, so 1,600 times 0.8, enter, 1,280, okay? And that's what it should be. So that means it is 0.8. So what we have to do is we have to multiply these values to get the next one. So let's try one more time. 1,280 times 0.8 should equal 1024. Let's see. 1,280 times 0.8, enter, 1024, and it does. Yay, it's good. So that's exponential. And not only that, but you can see over here that the growth rate, or the decay rate, is 0.8, right? All these are 0.8, right? So that's our decay rate, okay? So that's exponential. What is the beginning? Now, the beginning value is the same as we did before. It's that when t is 0, it's the first value for this one, which is 2,000, okay? Okay, the decay, we already figured it out. It's at 0.8, okay? Okay, what will the money be when time is equal to 6? Well, remember, we have 4 there, so that would be 5, 6. So what we have to do is we have to take 819, this one over here, and then we multiply it by 0.8. I'll just go like this, 0.8. What's that equal to? Let's see, that's 819. 819 times 0.8, enter. That's 655. So that would be 655 right there. But then we need to multiply that one more time because we want the sixth one, right? We want this one right here. So 655 times 0.8 equals, so 655 times 0.8 equals, so that's 524. So that should be 524. Let's see which one's the closest. So 3 is 524. So number 8 is 524. Finally, the equation is, remember, it's going to be y equals a times bx. Remember, this is the beginning. And then this is the growth or decay factor. So if it's getting smaller, it's decay. So we already know that the starting value is 2,000 and the decay value is 0.8, or the growth decay factor. So we want something with 2,000 and 0.8, and that's going to be A. Okay, here's a new function right here. Here's a new function. This is all we have to do is take this and put it in our calculator. So that means 5.5 goes right there. So we're going to go f of 5.5 is equal to 1900 times 0.9 to the power of 5.5. So we need to use our calculator, okay? So we're going to go clear 1900 times 0.9 to the power of, what is it again? Is 5.5. So it's to the power of 5.5, enter, and I get 1064. So that is this one right here, okay? So that is how you do this assignment. Now you can do the rest of the assignment. That was a first view, so now you can finish the rest of the assignment, which is going to be more practice questions on the next page. It says 5 through 10, but it should be 11 through 16, okay? So make sure you do those and then put your answers in Canvas.